All right, there you are with the answers to the warm-up. Go ahead and look at them and double check. We've got 465, $6.25, 21. This reduced to 3/5. This is 2, and this is 18. And then we get 30. So good job if you got all of those correct. We're going to talk about area of a triangle and then do some rectangular area and take it a little bit further. Now what we want to remember or learn, look at some vocabulary with triangles. Here we've got a triangle. Every triangle has a height, or sometimes that height is also called altitude. So this can also be called an altitude and a base. So here's a right triangle, and it's always easy to see a base and a height. Let's take this triangle here and rotate it around 3 different ways. This is the same triangle, just rotated or flipped. So here we have the base and the height. Here we could have whatever it's just sitting on. We can call it the base. It doesn't have to be the longest side. So we've got base, height. Here it is laying on its what's called its hypotenuse. So this is different because it's not 90 degrees straight up from these sides, so you have to draw what's called an altitude here. So from the base to the vertex across, and it should be a right angle. And when we do that, we get the base, and the height is from here to here. The base or the height is never the slant, because you don't measure someone standing up by a slanted ruler or tape measure. All right, let's look at these 3. Sometimes I think the hardest part about when you're doing the area of a triangle is sometimes locating the height, because there are a couple of spots where you can get kind of tricked. So here we are. If you have an obtuse triangle here and it's on its base, it's on a side. Yeah, it's not on the hypotenuse there. It's on a leg. And so our base is this, from the dark black here of the actual triangle. Now the height is really, it's the altitude. How tall is this triangle? It's from here straight up to, it's the distance from here to here. So in order to do that, we have to go out here and make a 90 degree, because we measure people standing up 90 degrees, not slanted down or leaning. So the height is out here. So the height is not always a part of the triangle. You have to find it sometimes. Here, the base, it's laying down. The height is from the vertex straight down 90 degrees to the base. And again, we've got this one where you've got to extend this out and extend this out to find the height. All right, so as long as you can look at any triangle and locate the base and the height, you're in good shape. And then we're going to go ahead and do the activity. You do need to have paper. You need a protractor, possibly a straight edge ruler, and you need some scissors. And then you'll be ready for that. So go ahead and get those supplies and then come back and watch what to do. we have learned the formula for area of a triangle. Area of a triangle equals 1/2 base times height. Just like it was in a rectangle. Length times width, but it's half of that. So it's almost like it was a rectangle, and then it's just cut in half. So it can look like this, 1/2 base times height, or base times height over 2. These are the same thing. They're synonymous. Here I wrote it this way. You'll see this a lot, and I use it this way when I actually want to answer a question. Area of a triangle equals BH over 2. So here they want us to find the area of this triangle using the formula. Now, just like I've asked you to do for area of a rectangle, we always start with the general formula, and then we fill in our data. So first thing I do, even if it's written right there, is we write area of a triangle, and they want us to use it this form, this one up here, not the 1/2 base times height. Later on, you get to use whatever you want, but they actually really asked us to do it this way, so we follow the directions. So we look over here and go, okay, my base is 5, and it looks like my height is 4. It is not 7. So we go ahead and write, put in parentheses, and our base is 5, our height is 4, and then we go ahead and calculate that. You can do that all in one step, or if you want to write 20 over 2, that would be fine. Equals 10, and we are centimeters, and we are dealing with area, so it's centimeters squared, or square centimeters. Example 2, they want us to use this formula, 1/2 base times height, and here is our triangle. So we're going to write the formula. This is what I'm going to require. Oops. Write the formula. So I always want to see that on a test. 1/2 base times height. Okay, and then fill in the information we know. The base looks like it's 4, and the height will be 3. So 1/2, 4 times 3. Now you can always do 1/2 of 4 is 2, multiply that by 3 is 6. Or you could do 4 times 3 is 12 and divide by 2, or 1/2 of 12 is 6. So sometimes I do a half of what's right here. 1/2 of 4 is 2, times 3 is 6 centimeters squared. Now they want us to find the area of this figure, and they tell us everything is right angles. So what we have here are something that looks like a rectangle with another rectangle attached to it. So there's 2 ways to do this. We could look at it as 2 rectangles this way, and we would find the area of this rectangle and the area of this rectangle and add those areas together. In fact, what I sometimes do is maybe say A and B. So I'm gonna go, that's area A and that's area B. Well, let's find the area of A. Area of A, and that's what that means. Area of A equals length times width. Okay, equals, now our length is 12, or our length is 10, it really doesn't matter. It's a 10 by 12 rectangle, and together that makes 120. So we can even say 120 centimeters squared in that box. An area of B, well, we've got to, we don't know how far it is from here to here. It's not 23, right? So let me go ahead and get this started on my area of B equals length times width, and we know that the width is 7. What is that length? Well, I can tell from here to here is 23, and from here to here is 10. So from here to here, 10 plus this equals 23 for the whole thing. So we're going to go ahead and say that's 13. So we've got 13 for that width, and together 7 times 13 is 91, and I should have written it this way. So just to have a visual, let's go ahead and write that there. And then our total area, which is what we're looking for. Yes, we have to write all this, and that's okay. So what we'll finally say is total area equals 120 plus 91. And when we do that, we get 211 centimeters squared for our final answer. Now, I'm not going to take this the other step, but the book does have it. The book showed two methods. See how we divided this down vertically? We could have also divided it into two rectangles like that, where up here was one and this thing was another. And you can peek in the book and you're going to get the same answer. But you only needed to show one method. Example 4, we're going to do it a little differently. Yes, we can look at this and maybe, obviously probably want to cut that. That's possible, but they're going to show us another way. They're going to say, what if we pretend like this was a big rectangle? I'm showing it with these dotted lines. And we subtracted, so like this, the whole thing, and we're going to take away the little thing. Or sorry, this whole thing, and we're going to take away this little thing. So we would say, like, let's call that A. Area of A. So we would take this whole rectangle, which would be a 10 by 20 area of the whole thing, and subtract the area of this rectangle here. So we probably need to know the lengths of these, right? Well, all the way down it's 10, and this is 5, and obviously not drawn to scale at all, is it? And that is pretty typical for a math book, because they don't want you to use your eyes, because it can be deceiving. We want what we can prove with numbers. So 5 and 5 make 10, and then this is 14, and this is 20. So this is a 6. So we have a 5 by 6 rectangle. So what we would do is find the area of the whole. So I'm going to say area of the W. Area of the whole thing equals length times width, and that's a 10 by 20. (200 meters squared). And the area of the little part, or we could say little, or whatever you want, length times width, is a 5 by 6, so it's 30 meters squared. So now we would say our final answer, area equals 200 minus 30, which would be 170 meters squared. Alright, so that's just another option. Sometimes you'll want to use that later on. Obviously, it probably would have been easier just to add the little one, but they wanted you to see different ways to do it. Now the next page is a practice set, and I just ask that you show your work. All of these things. It's okay. It's not going to kill you. You've got to get used to writing the formula, fill it in, solve every time. And we will be grading that on tests. So you may pause and then come back and check and really look for making sure that your work is shown properly. And you may begin. Alright, so basically I'm going to write area equals 1/2 base times height for each of these. So in this case I'm going to write area equals 1/2, the base is 12, the height is 5. So half of 12 is 6, 6 times 5 is 30, and these are all in centimeters. Okay, next one. Yes, I'm writing it over and over again. Make sure height is, that's the height, 8. So half of 12 is 6, 6 times 8 is 48 centimeters squared. And this one, we could do it this way too, BH over 2. So it is a 6, and the height is 6. So that's 36 divided by 2, or half of 6 is 3. 3 times 6 is 18. That's how I like to do those. There we go. Now it says copy the figure in example 4. And example 4 was this figure. So you don't have to draw it that large, okay? Let's draw a small version of it. Okay, by dividing the shape into 2 rectangles and then adding the areas rather than doing the subtraction the way we did it. So it is 20, 10, 14. Said that was 5. This is 5, and this is 6. So we can draw it this way. And so here's area of A, here is area of B. So area of A equals length times width. And I know I didn't leave a whole lot of room for this, but that's okay. So we have a 10 by 14. So 140. And I believe we were meters. And area of B is a 5 by 6. So our total area, I can even say total area equals 140 plus 30. And that should match. That is what we got on the last one, just showed another way. Okay, copy the figure in example 3, and we're going to do it by subtraction. So it'll kind of look like this. All right, and it was 10, 12, 23, 7. And we knew that was 13. And if all the way down is, this is a 5. So if we find the area of the whole thing, it would be a 12 by 23. So 12 by 23. And we do that, and we get a, oh, the book did it a little differently. No, the book showed both ways. So 12 by 23 is 276, and these are centimeters. Okay, and then the little one, area equals length times width. Oh, do you see what I did there? I made a mistake. I should have written, I needed to write area equals length times width. So yes, I would lose credit on this. I need that to be shown, okay? I know it's irritating, and when you get older, you can lighten up if your teacher lets you. But as of right now, your teachers will be very happy in the future that you learned to state your formula first and then solve your problem. So it's all right. I had to erase. I'm not going to die. We said it was a 12 by 23. And that was 276 centimeters squared. So there, I fixed my problem. Didn't take too much time. And now the other one is, I don't always have to do parentheses. I just like them for formulas, but we could say 5 times 13, like that with the dot. And 5 times 13 is 65 centimeters squared. Now our area equals 276 minus 65. And that equals 211. And there's our final answer. So yes, as we start doing big areas, that is a lot to show, and that's okay. But still not a whole lot of writing. You just might feel like it sometimes.